Hello everyone.
Hi, sir.
What shall we do today as we have covered all the topics of chapter 1 force?
Sir, we can discuss couple of important questions from the chapter 1 force for board exam.
Okay, let's do it. But remember, don't do any selective study as all the topics are important from board examination point of view. You have to understand each and every topic, develop conceptual clarity, problem solving skills by solving more and more questions like this. Let's begin. Okay, what's your first question?
Sir, a diagram is given in which a uniform half meter scale PQ is balanced horizontally across a knife edge. So, what we have to do is calculate first mass of the scale, second force on the knife edge, third is the state, the direction in which the force on the knife edge acts.
Okay, there are three subparts in this question and the diagram is given clearly. Okay, let us try to solve it on the whiteboard.
Yes.
Let's draw the diagram on the board, whiteboard.
Yes.
A uniform half meter rule. It's a
Uniform half meter.
half meter rule. Okay, 0 to 50.
50.
50 centimeter. A uniform half meter rule PQ.
PQ.
Okay, it's balanced horizontally across a knife edge. The knife edge. What is this?
Knife edge.
Knife edge or fulcrum. Okay, across a knife as shown in the figure. A weight of
35.
35 mass is equal to
35 gram.
35 gram is hung at the point P.
P.
From a distance from the knife edge is how much it is given?
15 centimeter.
15 centimeter. 15 centimeter away from the knife edge.
Knife edge.
Okay. So point Q. So what's your question? Find the mass of the scale. The mass of the scale is not given, right?
Yes, sir.
Yes.
So the mass of the scale, where it is supposed to be acting, the mass of the scale?
Obviously, sir, it will act at center of gravity.
Okay, at the center of gravity. Where is the center of gravity? Where it will lie? At
the middle.
At the middle, at the 25 centimeter.
25 centimeter.
So let I mark it as 25 centimeter. That's the midpoint, where it's called the center of gravity of this meter rule, where the whole mass of this scale is supposed to be acting. So let mass is equal to m. Put a question mark. All right. Okay. Now, what is the distance between this knife edge and the mass of the meter scale? This is 15. Of course, it will be 25 minus 15. That is 10 centimeter. Okay.
10 centimeter.
All right. So we have marked all the distances. So let the mass of meter scale be acting at the center of gravity at the 25 centimeter mark. Okay. All right. Now taking the moment, we can consider the moments about the knife edge. Moment is acting always about the knife edge. So we can write clockwise moment is equal to
anti-clockwise moment.
Anti-clockwise moment.
That is
All right.
principle of moment.
That is principle of moment. We are right. Okay. What is the clockwise moment? Which is the clockwise moment? Clockwise moment due to, see in this direction, right?
Yeah, in this
Clockwise moment due to the mass of the
Mass.
meter rule, which is acting at 25 centimeter mark about knife edge. And the anti-clockwise moment is produced due to 35
gram.
so that is anti-clockwise moment. This is clockwise
Clockwise moment.
moment. Okay. So we have marked it. So the clockwise moment is equal to anti-clockwise moment. This is one of the important application of principle of moments. So what is clockwise moment? Force. What is the formula for moment? Moment of force? Force into perpendicular distance. So what is the force here? That is unknown. M gram force into
10.
Into 10. That is the distance
Distance
is equal to what is anti-clockwise moment?
35 gram.
Force into perpendicular distance. 35
Into
gram
15
force
centimeter.
into 15 centimeter. You are correct. Now it's almost simplified, right? So you have to calculate m is equal to 35 into 15 divided by 10. All right. Okay, that's equal to 3 2. And
the answer will come as 52.5 gram.
okay, wait. Let us calculate. This is 17.5 5. All right, 17.5 multiplied by 3. You are getting it as,
52.5.
oh, you have already calculated it. 52.5 gram. What is the unit of mass?
Gram.
Gram. Don't write it as a gram force because it is a unit of weight. All right.
Yes.
Okay. This part is clear to you?
Yes,
Okay. So
sir.
we got the mass of the meter rule at a 52.5 gram acting at the center of gravity. Okay. Yeah. Now the second part of the question. So the mass we got it as 52.5 gram. Okay, we got it. Now the second part of the question I am writing here. Okay, can you see?
Yes.
Okay. The second part of the question, state the direction, the force on the knife edge. So what is the force on the knife edge? So of course the force on the knife edge will be, force is nothing but it is the weight. The weight due to the mass of the mass of the meter rule and the 35 gram.
So we add it.
So we will add it up. So the second part, the force on the knife edge. Force on knife edge is equal to, I have to add both, 52.5 plus 15. 35. Okay, 35. That's coming it as 87.5
gram force.
Okay.
That is
So
the
that's
force
so
acting on the knife edge.
that's the force acting on the knife edge due to this 35 and 52.5. All right.
Yes, sir.
Yes, sir.
Okay. Now the third question, I'm writing here. The third part of the question is
The direction
the direction. State the direction in which the force on the knife edge. Okay.
acts
So of course the force is nothing but the weight. The weight is always acting.
downwards.
It is downwards towards the center of that. So we can write the force is acting vertically downward.
Downwards.
In downward direction.
In downward.
Direction.
Downwards direction. Okay, we can write it is force is acting always vertically downward.
Downward.
All right.
Yes, sir.
Yes, sir.
The steps are clear to you.
Yes, sir.
So it
Yes,
carries
sir.
3 mark questions.
Okay, sir.
So simple as that. All right.
Yeah.
Okay. Now what's your second question?
So the second question is again a diagram based question. In the given diagram, wheel shown has a fixed axle passing through O. The wheel is kept stationary under the action of two forces F1 and F2, such that the first part is a horizontal force F1 at P and a vertical force F2 at Q. We have to show the direction of F2 in the diagram and which is the greater force. Find the ratio between the forces. Given PO is equal to 2.5 centimeter, QO dash is equal to 1.5 centimeter, and OO dash is equal to 2 centimeter.
Okay. Now let's try to figure it out on the whiteboard. Yeah, I have drawn the diagram on the whiteboard where it is by a wheel is balanced at the point O, a horizontal force F1 acting at the point P at a distance 2.5 centimeter away from the center. So the question is how you can balance this wheel by applying a force F2 in which direction? So look at this diagram. The force F1 acting at the point P producing clockwise moment. All right. So in order to balance this clockwise moment, we have to apply a force F2 at the point Q in the downward direction. Of course, we should apply force F2 in the downward direction at the point Q, so that it balances and remains stationary. All right. It produces F2 produces an anti-clockwise moment. Okay, which is at a distance of 2 centimeter from the fulcrum. O dash is equal to 2 centimeter. All right. So I write O dash is equal to 2 centimeter. OP is equal to 2.5 centimeter. These quantities are given. All right. So I can say that the force F1 applied at the point P produces a clockwise moment on the wheel. This wheel can be kept stationary by applying a force of F2 at the point Q in the downward direction, which produces an anti-clockwise moment. So therefore the force F2 must be applied in the downward direction. All right. Now taking the moments about the point O, all right, and applying the principle of moment. Let us try. In equilibrium, what happens? Clockwise moment. Applying the clockwise moment is equal to anti-clockwise moment. You know it. Okay. What's the clockwise moment?
F1.
Due to F1. So F1 into PO.
distance.
Yeah, PO, the distance. You are correct. Due to anti-clockwise moment, due to
The
F,
force is F2
F2 into
O dash.
O dash,
The
right?
distance is 2 centimeters.
O dash. All right. So we will take the ratio now. F1 by F2. We have to calculate the ratio of the forces, and we have to find out which is greater. F1 by F2 is equal to
O dash
O dash by
PO.
PO. You are correct. That's equal to
2
O-
by
O dash is equal to what is given? 2 centimeter.
centimeter.
2 divided by 2.5.
2.5.
So we can take it as 20 divided by 25. All right. Decimal places is removed. So that's equal to 4 by 5. Okay. So we got the ratio as F1 by F2 is equal to 4 by 5. So obviously
F2 will be greater than
F2 is greater than F1. Okay. F2 is greater than F1, which is acting at the point Q in a vertically downward direction. Is it clear to you?
Yes, sir.
Got it?
Yeah.
All right. Well, what's your third question?
So the third question is a conceptual question. So here it is. A, first part. On what factor does the position of the center of gravity of a body depend? Second subpart. What is the SI unit of the moment of force? B. Name the factors affecting the turning effect of a body.
Okay, fine. It's a simple question, a direct questions. We can solve it. On what factor does the position of the center of gravity of a body depend? First part. So as you know that the center of gravity depends on
Distribution of mass.
shape of the body or
Yeah.
distribution of
Mass.
shape of the body or
Distribution of mass.
distribution of mass. We have seen that center of gravity depends on the distribution of mass of the body. Sometimes it lies outside the body. In which example the center of gravity lies outside the body?
For example, CG of a ring.
In a CG of a ring, center of gravity
Yeah.
lies outside. In case of a boomerang. Okay. In all those cases, center of gravity is lying outside the body. Okay, where there is no material. Okay. Next, what is second part? What is the SI unit of moment of force? Moment of force?
Newton meter.
Newton meter. Moment of force, you know that given by force into
Force into
perpendicular distance. Perpendicular.
So the unit of force is Newton.
Newton
And the unit of distance is meter.
meter. Of course.
So
So Newton meter. SI
if
unit
we
is.
will derive it, it will come as Newton meter.
Okay. Good. Very good. Now, name the factors affecting the turning of a body. On what factor the turning of a body? Turning means the torque.
The torque. Yeah,
Difference.
The torque.
So we know that the torque is equal to force into perpendicular distance. All right.
Okay.
The force remains constant. So which factor is controlling the torque?
The
distance.
perpendicular
Distance. So we can write that the distance of point of application of the force from the axis of rotation. What is this D? The perpendicular distance
Perpendicular distance.
from the point of application of the force to the axis of rotation. So this perpendicular distance controls the
Is the
torque.
one factor which
Affects the torque. Okay. The fourth part of the question, what is that? You did not read that. What is that?
Define equilibrium.
Oh, equilibrium. What is equilibrium? So equilibrium actually it's a state of a body in which net force acting on a body, algebraic sum of the force acting on a body will be zero.
Zero.
Okay. For example, consider a book lying on the table.
So it will be stable equilibrium.
Yeah, it will be in stable equilibrium because
Static equilibrium.
the weight of the body is acting vertically downward and the reaction, normal reaction is acting vertically upward. So weight is balanced by normal reaction. So the net force, what is the net force? Is zero.
Zero.
So it is in equilibrium. So equilibrium is a state of a body in which net force acting on a body or a system is zero and the body is under
State of rest.
state of rest. It's not moving. Clear?
Yes, sir.
Crystal clear?
Yes, sir.
Okay. Okay, what's your next question? Question number 4.
The fourth question is again a numerical question.
Oh, you are coming up with a lot of numericals. Okay,
Yes,
fine.
sir.
Let us try to solve it.
On a seesaw, two children of masses 30 kg and 60 kg are sitting on the side of it at distance 2 meter and 2.5 meter respectively from the center of the seesaw. Find the distance at which a man of mass 75 kg should sit on the other side to balance the seesaw.
Okay, fine. It's again an application of principle of moments. You have to find the distance from the fulcrum, the man sitting. All right?
Yes, sir.
So I have presented the question in the form of a diagram. It is very important to know the things and put it into the form of a diagram. So on a seesaw, you can see two children of mass 30 kilogram and 60 kilogram are sitting on one side at a distance 2 meter
And 2.5.
2.5 meter from the knife edge or the fulcrum. You can see
Fulcrum.
2 meter and 2.5 meter. Okay. Find the distance at which a man of mass 75 kilogram should sit on other side to balance the seesaw. So of course this 30 kilogram and 60 kilogram mass is producing a clockwise moment, right?
Moment, yeah.
So it is marked here. So for a man he must sit on the opposite end to produce an anti-clockwise moment. To balance it, and the seesaw remains stationary in the horizontal
Remains
direction.
balanced.
Okay. So diagram is clear to you. So this distance from the fulcrum where the man is sitting, okay, this distance
We have to
OE,
find the distance.
OE is equal to D I have taken, that is unknown to us, that we have to calculate. Again, apply in equilibrium, we can write again applying the principle of moment. In equilibrium, we can write clockwise moment. Clockwise moment is equal to anti-clockwise moment, ACW. What are the clockwise moment? There are clockwise moment due to 2.
Yeah.
That is 30 into force into perpendicular distance. 2
That is
plus
60 into
plus 60 into
2.5.
2.5. That is anti-clockwise moment due to these two masses. Alright? Is equal to, clockwise moment is equal to anti-clockwise moment. What is anti-clockwise moment? 75. Force into perpendicular distance into D. Okay. So we are getting it as 30 into 2 as 60 plus 60 into 2.5, how much? Coming it as 150. Alright? Yes. 150 is equal to 75 into D. Alright? Calculations are correct?
Yes, sir.
Okay. So 150 plus 60, how much? 210 is equal to
75D.
75D. Now it is solved. You can solve it. That's equal to 210
By
is
70.
D is, I can write
D
D is equal to 210
by
divided by
75.
75. Solve it and see how much. Divide and see. Coming it as 2.8 meter. Okay. So the man should sit on the opposite end at a distance 2.8 from from the fulcrum. Clear? Simple application of principle of moment. Steps are clear to you?
Yes, sir.
Got it?
Yes, sir.
Okay, fine. Okay, what's your next question? Question number 5.
So again, it is a conceptual question.
Okay.
Is it possible to have an accelerated motion with a constant speed?
Okay, is it possible to have an accelerated motion with a constant speed? It's a case of uniform circular motion. Alright? Yeah.
Yes, sir.
Yeah, this is the case of a uniform circular motion. We have already studied. In uniform circular motion, the motion is accelerated because of the centripetal force, and the velocity is constantly changing. Direction of the body changes at every point, right?
Yes, sir.
So the velocity is changing at every direction.
But speed remains
The speed remains constant. Speed is constant. Velocity is changing because of the particle changes direction at every instant during the course of rotation. So speed is constant and the velocity is variable. Velocity is variable. So we call it as it is an accelerated motion because there is change in velocity. Since there is change in velocity, there is acceleration. So therefore, it is possible to have accelerated motion with a constant speed. For example, in case of a uniform circular motion. This is a case of uniform circular motion. Okay, in uniform circular motion, speed is constant, velocity is variable, acceleration is also variable. We have studied. Even force is also variable. Only one quantity remains constant is the speed remains constant. So it is possible to have an accelerated motion. All right?
Yes, sir.
So clear to you?
Yes, sir.
Okay, thank you very much.